This is going to be a problem solving in chemistry tutorial. Problem is about solution. Solution is a homogeneous mixture of one or more solutes dissolved in a solvent. In concentrations of these five, and I'm going to show you a problem about molality. Molality can be expressed in small letter m, which is equals to moles of solute over kilograms of solvent. Problem is, calculate the molality of a solution prepared by dissolving 10.0 grams of NaCl in 600 grams of water. The given are grams of solute, 10 grams of NaCl, grams of solvent, which is 600 grams of. Now, what we're going to do is convert because the given are not in moles of solute and kilograms of solvent. So first, we're going to convert the grams of solute to mole of solute. The molar mass of of NaCl is 58.5 grams per mole. Using that, we can convert the 10 grams of NaCl by multiplying the 10 grams by 1 mole of NaCl over 58.5 grams of NaCl. We can cancel the grams. Now we have the moles of solute. To convert the 600 grams of water to kilograms, and our conversion factor is 1 kilogram is equals to 1,000 grams. 600 grams of water multiplied by 1 kilogram of water over 1,000 grams of water. Canceling the grams of water, we now have the kilograms of solvent. Having the 0.171 moles of NaCl and zero point 0.6 kilograms of water, we can now simply input the values in the formula. Now we have the molar concentration of the solution, which is 0.285 molar. It's about colligative properties, which is about solution also. Colligative properties are properties that depend upon the concentration of solute, molecules, or ions, but not upon the identity of the solute. It includes these four, but I'm going to be showing you a problem about boiling point elevation. Boiling point elevation. Boiling point elevation, or the change in boiling point temperature, is the difference between the boiling point of the solution and the boiling point of the pure solvent. And our change in boiling point temperature is equals to the K sub B times M, where K sub B is the molar boiling point elevation constant, which depends upon the solvent, and the M is the molality of the solution. Problem. What is the boiling point of a 1.50 molar concentration NaCl solution? The given is the molality of the solution. Now what we're going to do is solve for the change in boiling point, because the first we have to solve the change in boiling point first, because the question asked is what is the boiling point of the solution. So first thing is we're going to multiply our mole concentration by 2, because in the solution we have two ions. So we have, which is the Na and the Cl. So we have to multiply it by 2. With 2 I mean. Now we can just simply input the values, because we have the molar boiling point elevation constant of water is equals to 0.12 degrees Celsius per molal. Now inputting it, we can cancel the molal. Now we have the change in boiling point elevation is 1.54 degrees Celsius. Just simply substitute it with the formula, whereas the change in boiling point elevation is equals to the difference of the boiling point of the solution minus the boiling point of the pure solvent. And deriving it, we can have the boiling point of solution is equals to change in boiling point elevation plus boiling point of the solvent. And the boiling point of the water is 100 degrees Celsius. So, inputting the values, we now have the boiling point of the solution which is equals to 101.54 degrees Celsius. About thermochemistry. Thermochemistry deals with the study of the heat, energy, and associated with chemical reactions. This heat energy is either released or absorbed. The first law of thermodynamics states that the change in internal energy of a system equals the net heat transfer into the system minus the net work done by the system. It is expressed in this formula: change in internal energy U or E is equals to heat, which is Q, and minus work, which is W. And our heat can be solved, has the formula Q is equals to the mass times the specific heat times the change in temperature. And the work is equals to the pressure times the change in volume. A balloon is inflated to its full extent by heating the air inside it. In the final stages for this process, the volume of the balloon changes from 4.00 times 10 to the power of 6 liters to 4.50 times 10 to the power of 6 liters by addition of 1.3 times 10 to the power of 8 joules of energy as heat, assuming the balloon expands against a constant pressure of 1.0 an atmosphere. Calculate the change in internal energy for this process. The given are the initial volume, the final volume, the pressure, and the heat. First, we have to solve the work because we are not given the exact amount of work. So, using the given, we have to input it, and pressure times the change in volume, which is final volume minus initial volume. We now have the work 500,000 liters times ATM. However, the unit of internal energy is in joules, so we have to convert it to joules, and our conversion factor is equals to 1 liters ATM is equals to 101.325 joules. Converting it, we now have 5.07 times 10 to the power of 7 joules work. So we can now input the values of the heat and the work. So the change in internal energy is equals to 7.93 times 10 to the power of 7 joules. Thank you for watching.